Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to look into the topic data analytical frameworks, more importantly on what is HBase. This will be also depicted by the students of third year as a case study on HBase. So what is HBase? So HBase is a distributed column oriented database built on top of the Hadoop file system. It is an open source project and it is also horizontally scalable. It is modeled after Google's Bigtable, which is a distributed storage system for the structured data. It provides capabilities that will be stored on the top of Hadoop and HDFS. Some of the major what the goal of the HBase is to host the large tables with millions of rows and billions of columns on top of clusters of commodity hardware. More importantly, it is the part of the Hadoop ecosystem which provides real-time random access, read and write access to the data that is present in HDFS, that is Hadoop file system. So some of the major big giants that use HBase are from Facebook, Netflix, Yahoo, Adobe and Twitter. So the goal is to host the large tables. The features, there are n number of features that are in HBase. So first it is scalable. So scalable means it allows data to be scaled across various nodes as it is stored in HDFS. It provides automatic failure support. So write ahead log, WAL log across clusters are present to provide automatic failure support. Consistent read and write, I told you this is a main important feature, consistent read and write, which provides, HBase provides consistent read and write access to all the data, and it also provides easy access for Java API for the clients, and it supports block cache and Bloom filters which is used for high volume query optimization. So the architecture of the HBase includes Zookeeper, HMaster, region server. All these are the parts of the HDFS storage system. Thank you.
It is well suited for application where random real-time access to large amount of data is critical, such as social network, IoT systems.
Now the architecture and key features. Let's dive into a technical side. HBase is modeled after Google's Bigtable and uses column family model. Data in HBase is stored in tables where each table has rows and columns. But unlike relational tables, each row in HBase have different number of columns. Each piece of data is identified by a row key and the column families are stored together. Optimize read and write performance. Another important feature is distributed architecture. Data in HBase is divided into regions and distributed across multiple servers called region servers. As the data grows, these regions are automatically split, ensures seamless scalability. Furthermore, HBase supports stronger consistency and automatic failure over, which means it recovers from failures without any data losses. HBase was integrated tightly with Hadoop for batch processing using MapReduce and its compatibility with other big data tools like Apache Spark.
Let's now compare HBase with other databases. Compared to traditional databases, HBase offers better scalability and flexibility. While RDBMS like MySQL or Oracle are structured with a predefined schema, HBase allows for dynamic schema design, meaning you can add columns, complex joins or ACID transactions as efficiently as RDBMS, so it's not the best choice for applications that need those features. When comparing HBase to our NoSQL databases like Cassandra, a key difference is the gap here. HBase is a CP, that is consistency partition tolerant system, while Cassandra is an AP, availability partition tolerant system. This means HBase prioritizes strong consistency, but its availability may take a hit in certain failure scenarios. Cassandra, on the other hand, sacrifices consistency for high availability, making it more suitable for distributed systems that prioritize uptime over accuracy.
Moving on to the use case, HBase is widely used in big data ecosystem for scenarios that require real-time analytics on massive data. One prominent example is Facebook Messenger, which uses HBase to store and manage billions of messages sent daily, providing low latency access to conversations. In the finance sector, HBase is used for storing transactional data that need to be processed in real time, such as stock price and trading records. Another example is Yahoo, large-scale data analytics for user behavior and targeting. One interesting use case is an IoT, Internet of Things application, where sensor data is collected continuously from thousands of devices and stored in HBase for real-time monitoring and analysis. Its integration with Apache Hadoop makes it a preferred choice for big data analytic pipelines that involve both batch and real-time data processing.
Advantages and disadvantages. HBase has several advantages that make it choice for the managing large dataset. Firstly, available scalable horizontally is a major benefit. It can handle data across many servers without any significant performance. This makes HBase perfect for organization dealing with big data where data growth is unpredictable. Secondary, HBase supported real-time random access, a large dataset allowing both read and write with low latency. This make it well for applications where users need to retrieve and update data quickly, such as messaging system or IoT monitoring.
HBase also benefits from its integration with Hadoop, which allows for batch processing using MapReduce or Spark, making it a good choice for both batch analytics and real-time querying. Finally, its schema flexibility is key advantage as it allows developers to define columns on the fly, making it easier to work with unstructured and semi-structured data.
However, HBase does have some advantages. One major drawback is that it does not support ACID transactions like traditional RDBMS. This means you can't rely on HBase for applications that need strong transactional integrity, such as banking system or complex multi-step processing.
Another disadvantage is the complexity of administration. Setting up and maintaining HBase requires significant expertise, particularly when dealing with large clusters, as it involves tuning both HBase and its underlying HDFS layer. Also, complex queries such as joins or multi-table transactions are not easily supported in HBase, so it might not be suitable for applications requiring relational data models.
Lastly, when HBase generates a strong consistency, it can suffer from high latency in some compared to database like Wiki availability. This makes HBase less suitable for systems that uptime over consistency.
To conclude, HBase offers several advantages for managing large datasets, especially when real-time read and write access and horizontal scalability are critical requirements. While it may replace traditional RDBMS for transaction systems, it provides an efficient solution for big data applications when scalability and speed are more important than complex queries and transactions. HBase is a vital component of HBase Hadoop ecosystem, and it widespread use in industries like social media, finance, and IoT underscores its value. Thank you.